In this video, we will talk about the reduction formulas. So here, the reduction formulas are basically certain powers of trigonometric functions. So these are basically what they are. These really, if there's something that you really want to know, make sure that you really know at least the sine and the cosine. So basically these have a power, and the whole point of this power is that you want to reduce it so that you don't have any powers. So see how you have this squared. If you just replace this with this guy, you lose the square already. So same thing with the tangent as well. I'm not going to derive these guys. You can derive them very easily. Basically, if you just kind of just look at, like if you add cosine 2 theta is equal to cosine squared theta, and then minus sine squared theta, all you really want to do is just solve for the sine squared theta, and then just try to use this formula for using Pythagorean identity. So you can kind of make it like 1 minus sine squared theta minus sine squared theta equals cosine 2 theta. So then you just have 1 minus 2 sine squared theta. Okay, I can subtract the 1 over. Oops. So subtract the 1 over. And then you just have negative 1 plus cosine 2 theta equals negative 2 sine squared theta. Then just divide by this negative 2. And you see that you have sine squared theta is equal to, this is going to give me a positive 1. This is going to give me a negative cosine 2 theta. And then just divide it by 2. Okay? So you can see that this guy is just this guy. And then you can easily do the other ones as well. Okay? So just kind of to show you, there's just basically rearranging the formulas so that you're losing the power. Okay? So here we will only do one example. Right now, it probably will not make sense why we are doing this, but later on it will. So here you want to use the reduction formulas to reduce cosine to the fourth x so that it does not involve any powers of sine or cosine greater than 1. So basically what you want to do is you want to take this cosine to the fourth x and you want to reduce until you either get something that's like cosine of x or sine of x with no powers. So right now you might be wondering, why the heck would we want to do that? And it actually works well when you get to integration in Calc 2. So you'll be able to, this is really hard to integrate in calculus. This is really easy to do in calculus. So being able to do it that way is going to be really, really helpful. So we're going to start off with cosine to the fourth x. So first, what we're going to do is notice that we don't have anything to the fourth power. Okay, we look at these formulas, there's nothing to the fourth power. But what we can do is we can write the squared as cosine squared x squared. Okay, and now I know what cosine squared x is. So cosine squared x is just equal to this guy, 1 plus cosine 2 theta over 2. So that's what we're going to do. So the inside is going to be 1 plus cosine 2. In this case, I'm going to write x because it's just an x over 2. And I'm going to square this guy. All right. So what I'm going to end up getting is I'm going to get 1 plus cosine 2x. This whole thing is squared. Divided by 2 squared, that's going to give me 4. So I basically have, let me pull out the 1/4. And I have a 1 plus cosine 2x squared. So now what I have, I'm going to have this 1/4. And then I have 2 of these guys. 1 plus cosine 2x. And then another 1 plus cosine 2x. All right. And now what I'm going to do is I'm going to FOIL this whole thing out. So I'm going to have 1/4, then 1 plus cosine 2x plus cosine 2x plus cosine squared 2x. So then what I get is 1/4, 1 plus 2 cosine 2x plus cosine squared 2x. Okay, notice that I'm still not done because I need to get rid of that squared. So I'm going to use this double angle or this identity again. So So I'm going to have 1/4, 1 plus 2 cosine 2x. Now, what is this guy going to be? Well, I know that cosine squared x is equal to 1 plus cosine 2x over 2. However, what is cosine squared of 2x? Okay, well, notice that here there was a 1 and this was a 2, so it kind of doubled. So if this was a 2, what is the next one going to be? It's going to be a 4. So it's basically just doubling. So notice here that even though this was a 1, this changed into a 2. This guy was a 2. Here it changes into a 4. So this guy is just going to be 1 plus cosine 4x over 2. So what I'm going to get is 1/4, 1 plus 2 cosine 2x, plus this guy we can write it as 1/2 plus 1/2 cosine 4x. Here, what can we combine? We can combine these guys. That's just going to give me 1/4. There's just 3/2 plus 2 cosine 2x plus 1/2 cosine 4x. And then at this point, you can just distribute the 1/4 if you'd like. But this would be perfect because here we can't combine it anymore. We've already have no more square functions and no more cubes or anything like that. Everything is to the power of 1. Okay, so yes, it's a lot of algebra, and not only that, but it also, you might look at it and be like, what was the whole point of this? So right now there really is no point other than just trying to simplify it a little bit better. But later on, I promise you, especially if you're going to take Calc 2, you will be doing this a lot. Okay.